Hello physicists, in this video we're going to leave our one-dimensional linear world and extend our understanding of kinematics to the second dimension, to two-dimensional motion. And 2D motion's not all that hard, but let's get some of the mathematics out of the way. So in one-dimensional motion, if this is a position vector, r, then the position vector as a function of time would either be in the I direction or in the j direction. And it would look like this, or it would just point upward. So either in only one direction, okay, I or j. Now, in two dimensions, if you remember from our study of vectors, any two-dimensional vector can be expressed in terms of a sum of some multiple of I plus some multiple of j. So basically, our two-dimensional velocity vector will be x of ti plus y of tj. Okay, so if this is r of t, this side will be x of ti, and this side will be y of tj. Okay? Easy enough, right? What about velocity? What about velocity? Velocity is the derivative of the position. So we showed that it is the derivative of the position in the 1D motion video. So what we're going to do is just differentiate this expression over here, plus y of tj. And that becomes the derivative of the x function with respect to t, I, plus the derivative of the y function with respect to t, j. So the velocity is also a sum of I and j. So that's intuitive and easy to understand. And finally, we look at the acceleration. The acceleration is just the second derivative of the position. So that's just the second derivative of x of ti plus y of tj. And we get the second derivative of the x function with respect to ti plus the second derivative of the y function with respect to tj. All right, so now that we have all of these expressions, we're going to now look at one of the most fundamental parts, of two-dimensional motion. And that is the motion in the x and the y directions are independent of each other. Okay? So if I were to drop these two objects, so this one I'll just drop like this, and this one I'll give a little horizontal velocity. So which one will which one will hit the ground first? And most people, if they've never seen this one before, they'll say the first one drops first because it's shorter distance. But it turns out that they both hit the ground at the same time, and there are lots of videos showing this demonstration. Okay? Both of them hit the ground at the same time. And why is that? Why is that? So if I were to change my position, because that's what motion is, a change in position. A change in position, and if I were to change it by some y value, okay, some y value, notice how it doesn't affect the change in the x. The x still remains the same. It still remains the same. In this one, this is especially true in terms of the velocity. What's important to realize is that the x velocity remains unchanged for the entire duration of the fall. And that's because any change in velocity in the y direction does not affect the velocity in the x direction. We know the velocity in the y direction changes because of gravity, but it does not affect the velocity in the x direction. And that is probably the most important thing to take out of this of two-dimensional motion. The components of the position velocity vectors, they're all independent of each other. They all behave independent of each other, and they all change independent of each other. So if you use that, then you can quickly see that they both fall at the same time. They both have to fall at the same time, because when you're moving downward, and assuming they start at the same height, when you're moving downward, height h, then it is only the y component of the velocity vector and the position vector. Only the y component has any effect on the change in position. The x component has no effect on the change in position, precisely because of how the components are independent of each other, which means the y component, if it's initially 0 in both cases, they will reach the same speed in both cases at the bottom, and they will accelerate at the same rate toward the bottom. So therefore, they have to reach the bottom by the same time. And now, using this principle, in the next video, we're going to be solving actual problems, and we're going to guide you through how to solve two-dimensional motion problems. Thanks for watching. If you have any questions, just let me know in the comment section. See you next time.